Is it visible?
Yes, ma'am.
Okay. So, you all know me. I'm Archana KV from EC department, working as senior assistant professor, and my specialization is especially into the communication systems. So, we shall discuss. I think yesterday, what was the discussion you had related to communication? You were there in the session. Morning.
Yes, ma'am.
What was the discussion
Uh,
regarding?
Srinivas sir told us the basics of communications, and he told us what all should be complete, what all should we read to crack Qualcomm.
So, sir has not talked about wireless, right? Nothing about wireless.
No, ma'am.
It was only about the modulation techniques and all, right?
Yes, ma'am.
Yes, okay. So I'll take from there. Now, you all know that basically the communications is an electronic communication that we are talking about, and you know that the signal has to be transmitted from the transmitter to the receiver, and we all know that there are basically two forms of communicating your message or information. That may be in the original analog form, or you can convert it into digital. So based on that, you will either have an analog communication system or you will have a digital communication system. Now, the communication system can be wired, wireless, optical. There are so many ways of communicating. But coming to the very important part, which is your wireless communication. Why? Because nowadays everything has been wireless only. Because now we don't want to be hooked to one place and just be limited by the wires there. We want to be anywhere, any part on the globe, and still be able to communicate. So over a period of time, the mobile or wireless communications has gained more popularity there. So let us see that when I'm talking about wireless communication also, there could be different technology, there could be different systems of wireless communication that can be used for various purpose. It may depend upon application, it may depend upon the usage, it may depend upon the functionality for which we want to adapt. So there are various ways of doing this wireless communication. But I will be exploring only the cellular communication. The other competitive wireless communication methods being the Bluetooth, the Zigbee, the Wi-Fi. Wi-Fi is the more nearest one there. Okay. So you have near field communication. There are so many there. Okay. But I think the widest and more useful one is your cellular communication, and cellular communication has been advancing itself into a very advanced stage as of now, which it has started from its earlier 1940s or 50s with a very simple system, and that is what you call it as generations of cellular communication. It's not generation of wireless communication, it is generation of cellular communication standards, how it has evolved. So that will be our exact discussion, like how this cellular, what is this cellular communication, which is basically a wireless communication form, and how it has evolved, how it has changed from the very basic first generation, and now already there is a deployment of 5G in some parts of the world. It has been already started, whereas in India it is about to, and people are already talking about 6G and 7G. There are kind of research going on in that direction also. So just let us see what are the features of each of these generation. So this will be our discussion, that is what is the principles or the concepts behind wireless communications, and what are the different existing wireless systems that we are using, and basically focusing on the cellular wireless connectivity. And when we talk about cellular connectivity, there have been different generations starting from 1G going up to 5G and 6G now. Okay. And then let us explore a few technical specifications, like what is the bandwidth, what modulation scheme has been used, how much data rate is supported, what applications are governed. So all those things, and let's see what could be the best this one best standard that is good for usage for all of us there. Okay, so just talking about the basics. So communication is an essential need of human being. Example, conversation. Letter, yes, we know that either we talk in real, like human to human, or else we may be communicating via letters. So now this is the other mode which is wireless, used to be the only way to communicate in ancient times. So but mostly it was limited and it was unreliable. It was limited and unreliable. So, even you could see some in some places, or you might have read, like they used fire and all in order to communicate there. Okay, so basically it was a wireless there. But what wireless communication we are talking is, it is using electromagnetic field theory. It is using EMI waves that are present in the air, which are manipulating themselves as frequencies there. So that is the basic way we are communicating. It is invisible, and we are using electromagnetic waves as our means of signal carriers there, and that is what we call it as wireless communication, not using the very basic or old method like fire and all, like the drums or something like that. So wireless is often prior to its wired counterpart, and has become an important supplement. That is what I was telling you, that basically the kind of communication we were talking are wired there. Okay, but all of you know the problems with the wired communication part. Still it is existing, it has not completely gone out, but most of the areas the wireless has been replaced with the wired has been replaced with the wireless there. So if you see how it has happened, like you have Marconi's wireless telegraph initial days, then you have wired telegraph, telephone, then it has advanced in terms of cordless phones, semi-wireless it is, and then fully wireless, that is cellular telephone, and you also have the wireless local loop there. Then you could also see that how the evolution has happened in terms of broadcast TV. So you have broadcast TV has laid down towards cable TV, and cable TV has eventually been replaced by the satellite TV. So that's how you can see that the one for our voice communication we had wireless telegraph, then wired telegraph, telephone, cordless, cellular, and wireless local loop. Whereas if you talk about television transmission from broadcast TV to cable TV, it has come up to a satellite like Tata Sky, Jio and all there. And what about our computer networks? Computer networks which were very much wired in nature, like the very initial computer networks, Aloha networks, which you already have an idea. And then the Aloha networks were advanced with the Ethernet networks, which is basically a wired computer networks, and that has again led to the present day wireless local area networks with high speeds. Now, if you are talking about what basically wireless communication system comprises of, so what are the good things about it and what are the problems that we need to face. So one thing is wireless communication provides convenience, and it has also supports a reduced cost. Why? Because the service can be deployed faster than fixed service. So it is like deploy and start using there. Okay, plug and play kind of thing there. Okay, you need not do much of the setup there. So you, wherever you want to have the wireless network setup, it's just one particular one or two devices. You just on them and you start using it. And that also no cost of cable plan there. So you are not going for heavy investments there. And then you are having service in mobile deployed almost anywhere. You can use it anywhere. Whereas for the wired counterpart, you need to think about the geography, the location and all, that matters a lot. Whereas in hilly region, in very unwarranted regions, you can still go for wireless. So one thing is that the channel, the medium that we are using in wireless is an air as a medium, which is highly unreliable. Why? Because there is lot of attenuation present, the signal gets faded, the signal gets shadowed, and there is lot of interference present. So always this is the challenge for a communication engineer when he is using wireless communication for data transmission. You have to overcome attenuation, fading, shadowing and interference kind of problems when you are using wireless communication. Though these all are the advantages, but unreliable channel is the most problematic part of wireless communication. Then coming to complicated design and management. Sometimes the design of transmitter and receiver may be complicated owing to the factor of channel complexities. Then there are device limitation. So it is not like the wired counterpart, wherein you can have infinite continuous supply of power and there is no limitation on any of the device features, nothing like that. Whereas in wireless you have all sorts of shortcomings there, like in power supply, the LCD screen and all, small screen and all. And the most important problem that you will have in wireless communication is the bandwidth is limited. The bandwidth is limited. Within that limited bandwidth, you are supposed to support a huge number of users, and that may lead to expensive services there. Right. Let's also see, are you following? The speed is fine?
Yes, ma'am.
Okay. Now, let's also see where all the wireless communication can be used, in which all industries it will fit. Maybe the construction industry, wherein scheduling construction phases and employee travel, completing payrolls, diagnosis equipment, all this because this is a temporary work, construction works and all. So you need not go for a fixed wired network there. You can always rely on wireless communication, which can be temporarily set. And then warehouse management, wherein you want to talk about the process like inventory, shipping, reading, barcoded pallet labels. All these things can happen in a wireless mode there. Why? Because it will be a huge area. You need to move from one part to another. It makes no sense using wired devices. And one more important area where wireless communication can find its usage is the healthcare. So why? Because you have tracking dispensed medicine there, verifying patients' barcoded armbands, accessing patient records. So you can all think about what advantage you will have and what liberty you will have if you are moving towards the wireless communication in few of these areas. And talking about the advantages, talking about what are the overall advantages and disadvantages. First, about the advantages, first important thing is definitely because it is wireless, I have the flexibility to move anywhere. That is the mobility there. Then next is easier and less expensive installation, as we have already discussed. Then increased reliability. So because of added, it's actually not reliable, it is unreliable, but by adding some algorithms at transmitter and receiver, we can always make the communication highly reliable. Then disaster recovery is possible there. Then disadvantages, one thing is it's questionable, but people still talk about health risk both to humans as well as the birds and other animals there. So first, few studies, a few research have indicated that there is a kind of a risk because of the radiations involved in the frequencies there. And then you have radio signal interference. Yes, because wireless communication, I said you, there's just not one form. There are so many forms existing, coexisting, like in FM radio, AM radio, satellite TV, wireless LANs, and then cellular networks. So many are there. So one could interfere with the other there. And then most again problematic part is the security, because we are throwing our data into the air, so there is no control over what we are transmitting, who sees the data, who receives the data. So cyber security or security aspects have gained more importance. Why? Because we are doing our the important transaction. Even fintech applications are using wireless, and definitely we have to be more careful, and people are exploring more security related aspects when they are talking about wireless communications. Now, starting with our the basic wireless communication system, entire system, you know that we need at least a minimum a transmitter and a receiver, and because it is wireless, antennas become an integral part of your communication system. We must have a receiving antenna and we must have a transmitting antenna there. So basic communication will involve transmitter and receiver, transmitting antenna, receiving antenna, and most importantly that is the air as the medium, which is nothing but the environment or the channel that we are using there, right? And please remember this in any case, in any form, you have to remember this frequency spectrum there. So because this is the foundation for any wireless communication. So you know that the whole air as medium comprises of electromagnetic waves, and those are nothing but in the form of available in the form of frequencies, and the whole frequencies have been divided into particular ranges, and each range is meant for a particular application there. So based upon the value of the frequencies and the application, we have very low frequencies, medium frequencies, high frequencies, very high frequencies, ultra high frequencies, super high frequencies, and extremely high frequencies, then coming into the infrared rays, and then coming into the visible light. So your application may be maritime shipping application, as we told, it can be wireless LAN, it can be TV, satellite communication. So you have to check which band is useful for which. All these frequency bands have been already occupied, have been already completed there. So now people are searching for new spectrums because we need to support whole number of lot number of users there, which is day by day increasing there. Now even people are talking about infrared communication, that is your Li-Fi communication also, and again people are also talking about how this visible light communication can also be explored there. So there are wide range of research coming on how to use just not this the radio frequency spectrum up to EHF, which is already overcrowded, whereas people are exploring now the infrared and visible light also. So just based upon your frequency band, radio spectrum band that you will be using, we will also talk about what kind of medium, what kind of transmission medium or channel is most suitable. So if you take extremely low frequencies and coming up to very high frequencies, even the wired cable, that is twisted pair communication using twisted pair is also very much viable there. So if you are talking about cable TV uses coaxial cable, which is falling from very low frequencies and coming up to ultra high frequencies there. And if you see this medium frequencies, it is mostly used for the AM radio there. And if you are talking about the band of frequencies in VHF, am I audible?
Yes, ma'am.
Yes.
Archana,
Ma'am?
in between 1 minute you lost connection, but now it's okay.
Yes, ma'am. Is my slide visible?
No, ma'am.
No.
No, ma'am.
Now? Yes, I think, right? So we were discussing about, am I audible?
Yes, ma'am.
Yes.
Okay. So we were talking about how the whole air frequencies have been divided into different regions and how they are able to serve different applications there. Okay. So anyhow, I will be sharing these slides. You can always have a look into it. Okay. So one more thing you need to note down is that when it is a wireless communication, I mean anybody can use any frequencies for their devices and for their applications there, but you know that there has to be a central management in every country and in every region so that they can just take care of any liabilities or any interferences between the applications there or any disputes that arises. So you can see that in every country, in order to manage these frequencies, you are having some committees there. For example, in United States it is FCC, Federal Communication Committee, and in Canada it is IC, then in Europe it is ETSI, and then Australia CITIC, and then Japan you have TELEC, and then Brazil you have Anatel, and we have in India like in DOT, this TRI, these people are taking care of all the standardization policies related to who will be using which frequencies, and usually you have these frequencies divided into three different types. You usually call it as a licensed band of frequencies, unlicensed band and shared band. If you are saying it is a licensed frequencies, it means that definitely you need to take permission from government in order to use these frequencies there. For example, anybody who is interested in giving a cellular communication service cannot do on their own. They have to approach government and they should seek the permission and get the spectrum allocated from the government like Jio, Airtel and all that. Whereas if you are talking about some wireless devices which are to be operated without anybody's permission, like in the wireless LAN and all, we don't seek anybody's permission to use it in any house or in any corporate office. We are free to use it. So those devices and those communication come under unlicensed bands, like in 2.4 gigahertz, 5 gigahertz, and some other frequencies are also coming under these bands, in which you don't require permission from any central authority there. You are free to manufacture the devices in these range and use them for your services there. So in any case, there has to be some central management authorities who will take care of who will be using which frequencies. Basically, frequencies are licensed, unlicensed, and a shared band could be for licensed as well as unlicensed then. Okay. So then just now I told you that what are the frequencies that can be used in unlicensed band. It is not all. Whatever VLF, very low frequencies, medium frequencies, UHF, SHF, whatever I gave you that band of frequencies, those definitely require government permission, authorities there. Whereas these frequencies, what are mentioned here, they don't require anybody's permission to use it. Like in 2.4 gigahertz, 5 gigahertz, and a short range within 6 gigahertz band there, okay. And then there is again 57 to 64 gigahertz, which can be used for point-to-point and multi-point links, which you call it as 5G backhaul. For the back-end communication, they are using it, and also for the fixed or wireless fiber access there. Then again, a range from 71 to 76 and 81 to 86 is also being used as cellular or 5G backhaul, but it is unlicensed. They need not seek any permissions there. Okay. Then, as I told you that cellular or mobile communication is not the only form of wireless communication. There are many different forms. It all depends upon what is the technology, underlying technology that you are using, and what is the usage, what is the application. Like in cellular systems is the most fundamental and most important part of wireless communication systems there, and this I think aims for most of the 75% of the whole wireless communication systems there. Then you have a home RF standard there, okay. So now almost nobody is talking about this because Wi-Fi has taken over almost this home RF there. Then still we use Bluetooth for connecting our headset, or we also used it recently into the COVID there. It was Bluetooth which came to our rescue there. So Bluetooth has its, but it's a very limited distance there. And whereas you know that wireless LANs are the most widely used in campus, in office, in-house kind of wireless communication, we don't rely on cellular communication for this. And definitely a more bigger part of communication, wireless communication belongs to our the very old satellite communication system and paging systems there. And there is also a kind of fixed wireless access wherever the last mile connectivity is not possible with the wired, they just go for the fixed wireless access also, maybe in hilly region and all. Then also you have a wide area wireless data services there. So again, a different look at the different standards. These are different technologies as well as different standards there. And what is the difference between these is that basically the range, basically the distance, how much distance they are covering. Whereas Bluetooth is very small range, just 10 meters there. Whereas satellite you can see is worldwide there. There is no limitation there. Whereas 2G, 3G, all cellular standards are going for nationwide, countrywide it is. Whereas if you are talking about the wireless standards there, local area network standards, it is up to few miles or few feet there. Okay, so you have speed. This is also an important aspect. Distance and speed. This is what matters, right? And you can see that less the distance, more will be the speed. More the distance, less will be the speed there. But we want to make it reverse. Higher the distance, we still want to have higher data rate, and that has been the target throughout there, right? So are you following? Am I fine?
Yes, ma'am.
Okay. Now, as I told you that there has been lot of evolution, lot of development in wireless systems, just starting with the simple radio that was invented by Marconi in around complete 2 centuries back, 1896. Communication by encoding alphanumeric characters in analog signals there, and sent telegraphic signals across the Atlantic Ocean. So though we say that digital communication is a very recent, but you can owe to this telegraphic system as one of the oldest form of digital communication system, because in digital communication we use only 0 and 1 as our symbols, whereas in telegraph system, wireless telegraph system, Marconi and the whole group almost used all the alphanumeric characters. You know that you call it as a Morse code, using dots and dashes in order to form your message across the transmitting and receiving systems there. Then there was a first public mobile car based, you could have seen in old movies and all, like long antennas the car will be installed with. That is your oldest car telephone system, which you call it as MTS, almost 1946 there. That used analog frequency modulation, and it was high power base station tower to cover 50 miles of radius. It is almost like covering a whole city there. Okay, and that's what was the inefficiency in terms of 120K spectrum for just one voice communication, which is very costly affair. Then there were again advances in terms of improved mobile telephone system, which you call it as IMTS in the year 1960s, which was a more advanced version, like it supported full duplex services. That is both the parties can talk and receive at the same time, and then it supported 23 FM channels with the bandwidth reduced to just 25 to 30 kilohertz. Now you are approaching towards a cellular communication system. It is a kind of one of the first kind of cellular communication system. So you can see that a little bit of cellular concept was explored. What is that? Exploits the attenuation of radio signal with distance to achieve frequency reuse. So this is the very foundation of a cellular system, that instead of using a very high power transmitting antenna and covering a very high distance, long distance, why not use low power transmitter and limit the transmission range there, so that I can also again use the same frequency and again use a low power transmitting station, and it can be using the same frequency, because you know that we have there is a dearth of spectrum, there is a dearth of frequencies. If I use the same frequency, you know that there will be interference, and if I don't use, I cannot support the whole capacity, I cannot support more number of users. So this was a contradiction they had always on their mind. So what just a change in thinking was, I will still use the same concept of transmitting to the whole place there, but instead of highlighting and instead of covering a whole city, why not I cover only a part and limit my power? And that was basically what the property of radio signals you have, which gets attenuated with a path loss formula as the distance increases there. And this was originally proposed by D.H. Ring in 1947. He was a kind of founder for cellular communication, and Bell Labs were the first to start off with this cellular communication technologies. Now, already I discussed a few of the industries where the wireless communication can be used there. So we can still generalize it to education, military, business, entertainment, travel, construction, warehouse management, healthcare, and you know that in education it could be covering a classroom, presentation, libraries, access anywhere on campus. Then in military it could be a universal handset device, allows full motion video, cellular and satellite communication. And then in business it could be an office space where traditional infrastructure does not exist, or it could be a conference room or a hotel there. You know, as of today, you don't even think about wired counterpart. We already, at least your generation, don't even think that, I don't even think that you all may be aware that these all things used to happen with the wired part also, but it is no more now. So you could see that how big the wireless communication industry is, and it is having so many patents already granted, and then so many patents, 117745 two patents are already again into application mode there. Okay, so this is the kind of coverage over the whole globe there. Okay, so how wireless research has been taking over, and that's what I told you. There are so many choices. You choose, you select the application, you choose the form of wireless communication there. So this is another figure which clearly states when to use which kind of wireless communication mode there. Okay, so based upon the range in the x-axis, and then you have the speed there, you could see that range, the lesser range, which are the existing wireless communication technologies, and what are the data rates they are supporting there. So lower range you could always find Bluetooth, which is a very commercial this one technology, whereas Zigbee is more of a industry standard low range wireless communication standard, mostly used in small scale industries and all. And then you could see that the data rate is also not very high. It is a kind of medium data rate supported there, whereas range is not that high, and data rate are also a kind of okay. That is nothing but our wireless standards there. And in wireless standards also, IEEE has different versions supported there, depending upon the data rates, the peak data rates, the technology used, the modulation scheme used, all those. You will have so many. 802.11 is the basic standard.
Your voice is not audible. Hello, Archana? Hello?
Ma'am, I think ma'am will reconnect after some.
Am I audible?
Yes.
Yeah, okay. So, so you could see that this picture will provide you a very clear idea about what kind of data rates are supported and what kind of devices, which range is possible there. So, ultra wideband communication, if you take, it is the highest kind of data rate it supports, but the range is very small. I think the biggest form of wireless communication comes in the form of cellular communication, which you have 1G, 2G, 2.5G, 3G, 4G, 5G also now what we are talking about, basically supporting voice communication as well as data now. And now you could see that it is covering a range from medium up to the farthest nationwide. It could be going up to a nationwide coverage there, and you could also see that the data rate is also increasing there. So these are the different options you have for wireless communication. And one more way of showing your coverage, you could see that satellite link or satellite communication is having the farthest reach there, and then coming to your radios there, and then FM, medium wave, short wave, all these kind of radio communications there. And then you have mobile telephony and then wireless LANs. These are all in terms of your distances. It is in terms of the distances. Then coming to the wireless LAN, and then coming to your Bluetooth there. Okay. So this is the complete kind of how much range each particular communication system supports there. The least being Bluetooth and the maximum being the satellite links there. Now you could see the difference between the mobile telephony and the difference between FM radio. See, FM radio, one FM radio per city is enough to transmit and receive the signal there. Whereas if you talk about mobile telephony, it is almost a similar concept like FM radio, but you are replacing one powerful high power emitting station with low power emitting stations, so that you can limit the frequency of range there, and you can reuse the frequency. Frequency reuse is the main concept there. Okay, now if you are talking about any form of wireless communication, definitely you will have these issues there. What are the problems? There will be fading, the signal gets faded over a period of time. Then you will have multiple paths. Your signal will not have just one path, line of sight path there. It will traverse through the buildings, the trees, all these obstacles, and then reach the receiver there. So you have to take care of that. And then the signal may get diffracted by the various objects present between the transmitter and receiver, or the signal may get shadowed, and definitely there will be a lot of interference present. And very much part of communication is that in presence of noise we want to extract our signals there. Okay, so this is what I gave you a general form of, the general concepts, how the wireless communication looks like, what are the options that you have there. Okay, so as we are targeting ourselves and we are restricting ourselves in this class about only the cellular wireless communication. So let me start go deeper with the wireless cellular communication standards. Any doubt till now? Anything you have on your mind?
No doubts, ma'am.
Okay, so let's start with the not the wireless LAN or the Bluetooth or the ZigBee or the satellite communication. They have their own technology, they have their own method of transmission. Now let us concentrate on the cellular form of wireless communication. As I told you that, you could see in the picture on the left hand side that there is small hexagons, and then this smaller hexagon is again forming one big hexagon. So you could see that some 7 to 8 small hexagon is forming one group, and then second group, and again third group. Whatever you see the smaller hexagons with the capital letters A, B, C, D, E, F, G, H, those you call it as the cell. This you call it as the cell. As far as I think you all know these concepts there. These were covered in some subject. In mobile communication, it was covered?
No, ma'am. It was only for those who have selected this as their
right.
professional.
Okay. So you could see that these are nothing but A, B, C, D are nothing but group of frequencies, non-overlapping group of frequencies. Means in this area, in this zone, A set of frequencies are used, B set of frequencies, C, D, E, F. It means that all these frequencies are not interfering with each other. They are highly different set of frequencies. So that's why you are putting them one beside the other. Whereas now you can see that A set of frequencies I am again repeating here in this location. Now you see that between A and A there are B and F. B and F zone or set of frequencies are there. So this is almost the distance has increased. So you will see that because in the increase of distance, the signal will fade, and the A set of frequencies and this A set of frequencies will not interfere with each other. Same is happening with B. Do you find in this figure anywhere wherein same set of lettered frequencies are close enough by just one cell? I think always they are at least separated by two cells, yes or no?
Yes, ma'am.
Yes, so that you will not have the interference problem. If you are repeating the same frequencies also, there is no problem. For example, I am sitting and talking in this class. So if somebody else is taking the class in the same room, definitely there is an interference because our voices will clash there. Whereas if I go to the next class, somebody is taking, there is no interference, but we are talking in the same tone, we are using the same frequencies, but there is no clash. So that is the same concept. The whole set of frequencies that gets completed in one go, you call it as a cluster. This is a cell, A is a cell, B is a cell, D is a cell. This, when you complete the whole set of frequencies that are allocated by government to you, and then you complete that, that is called as cluster. This is what the Airtel and Jio and all people will do there. They will use all their frequencies in one area, and again they will repeat them, and again they will repeat them. This is how they cover the whole city there, and again they are repeated in the next cities there. So that's why you don't have interferences. Now break the metropolitan area into small areas. Each area is approximated with a hexagonal cell. It is just the shape of the cell is hexagon. That doesn't mean that exactly it is an hexagon. And you call it as a base station is located at the center of each cell. Base station is nothing but the tower that you see on some of the high-rise buildings there. Each cell is assigned only a fraction of total number of channels. Channels are nothing but frequencies. Cells that are sufficiently far apart can reuse the same frequencies. In the US, there are currently 200,000 base stations. And what are the features of a cellular system? Already I spoke that it offers a very high capacity in a limited spectrum. Because I am repeating the frequencies, you will increase obviously the capacity or the support for the more people will increase, whereas the spectrum is not increasing. You are not increasing the spectrum. The main reason behind that is the concept of the reuse of radio channels in different cells. I am using the same frequencies but a distance apart, and it will enable a fixed number of channels to serve an arbitrarily large number of users by reusing the channel throughout the coverage region. Then communication is always between mobile and base station. Don't think that when I make a call directly it will be received by your friend's mobile. It will be definitely first going to the base station. Only then the other person will be receiving it. Each cellular base station is allocated a group of radio channels within a small geographic area called a cell. Neighboring cells are assigned different channel groups. By limiting the coverage area to within a boundary of a cell, the channel groups may be reused to cover the different cells. That is the main concept here. And what will happen with that? The interference levels can be kept to a tolerable levels. And then frequency reuse or frequency planning is being adopted. Organization of wireless cellular system. Cellular network is organized into multiple low power transmitter with each 100 watt or less than. So that is the main difference between FM communication system or radio communication system and the cellular system. FM will use one high power transmitter per city, whereas cellular communication is using low power transmitters placed at frequent distances, which will be non-interfering way. Okay. So how this is happening? See here, the cell now I am showing not as hexagon but as a circle, which you call it as a channel 1, and here you are calling channel 2. So when you are in a mobile way, I mean when you are in a vehicle, definitely you will be over a period of time you will move from your first base station, and when your vehicle is here, you have to get rid of the first base station and get connected to the second, and this will happen without your knowledge. That is what you call it as the handoff. Then there are different various ways how the handoff is being done. There could be a hard handoff, there could be a soft handoff, there could be a softer handoff. There are many ways of doing this handoff there. So mobile must be transferred between cell as it moves, because the set of frequencies this base station is handling is different from this set of frequencies. So when I move from this cell, because this coverage is getting over, now you are coming to a second cell, you should be assigned the other frequencies without your current communication getting stopped, or without your current communication being deactivated. Without the knowledge of the user, this must happen. That is what you call it as a handoff, moving the active connection from one base station to the another base station. And how it can be done? It can be done in a hard handoff form. It could be a soft handoff, which is the very basic concept of technology called as code division multiple access, which was the foundation of 3G systems then. And then coming to softer handoff, which is supported via sectorized antennas, and there could be a possibility of a dropped call there. So you can see that transmit power drops off with a distance. True, that is what we said now. When you are far enough away, you can reuse the channel. We are doing that here. Similar concept of frequency reuse of radio and television stations. So you can see that same thing I am doing here. Channel 1, channel 2, channel 3. Again I am repeating channel 1. Between channel 1 and channel 1, you have channel 2 and 3. That's why if I make use of same set of frequencies again here, there is no overlap. So low power transmitter, the transmitter is transmitting only in this zone. It is not spreading up to here. This concept is what you call it as frequency reuse. So I am just again just broadening and showing you, like set 1 is here and then set 1 is completely repeated here again. Set 2 here, there is no nearby set 2 is again repeated here. Set 3 is here, so you can see that blue colors are set 1, green colors are set 2 and grey color are set 3, and then you have a pink color set 4, somewhere else set 4 will be repeated. Never set same set values, you can see they are not close enough, they are not nearby. Low power transmitters provide coverage to a small portion of service area. Frequency is being reused. That is the main idea there. So you could see that the coverage of a particular base station you are showing with an hexagon. We can assume that at the center to this cell, hexagon cell, there will be the base station, and then it will completely cover all the mobile devices or systems which are in this region. But this is a very idealized way of saying, because I don't want to miss out any non-overlapping, or I don't want to have any overlapping regions there. That's why it is an idealized cell shape there. But actually speaking, it will be round and you will have some overlapping areas that you could see here. Okay, but this is also again a kind of idealized. If you see actually in reality, this will be the kind of the coverage. So you don't call it as coverage, you call it as the footprint. This is called as the footprint. So you can see that this is one hexagon, but the shape is not hexagon. This is the actual way the things happen there. Now there is a base station here, base station in green area, base station in pink area. This is how the actual things look like. So as I told you that in order to reduce the interference, you could have seen this kind of arrangement when you are moving here and there on the roads and all there. Now instead of having a single antenna, there are 3 sectored antennas that are being used, so that you can reduce the interference. Even for a single base station also, you are not having one base station and one antenna, but one base station is being used with 3 sectorized antennas, so that each sector will handle again a subset of frequencies, so that will reduce the interference there. Now, just for your understanding and just for your knowledge, I wanted to give you how is the internal structure of our phone. Be it a very simple cell phone or be your smartphone like in your iPhone and OnePlus like that, whichever are the costliest one, leaving other features. definitely any mobile phone, cell phone, if you see internally, these will be the components, these will be the blocks that will be present. So you have an antenna, the antenna usually doesn't come out, it is integrated and it is within the device there, which you cannot see there. And you could see that the first section comes is the RF section. Why? Because every mobile phone will be using a different set of frequencies, and then those frequencies, I may be doing a voice call or I may be on a data, whatsoever it is. So those I have to get rid of those RF frequencies which were assigned to me when there was a call initiation. So once you are out of that high frequency that was assigned to you, the carrier is you are getting rid of the carrier, and now you are in your baseband region. So you get to your original voice range, which is from 400 Hertz to 3.1 kilohertz, and in that you will see that you will have A to D converter, D to A converter, digital signal processor and encoder. This is what when one is speaking, he may be using a microphone, and one is listening, he may be using a speaker. So this is your data that is getting converted to baseband, and then this is the real world communication there. And to control all these things, I require a controller that might be any like MSP 430 controller, some kind of controller is required there. Okay. So now coming to, is it clear up to this cellular concept?
Yes, ma'am.
Fine. Okay. So what we did was, now we just saw what is the difference between the analog communication, digital communication, and analog and digital communication, how it is different from the wireless communication. Wireless communication is the subset of your electronic communication, and wireless communication could be analog communication or it could be digital communication. Both forms are supported there. But it is very different from your wired counterpart. That is what we saw, and there are certain challenges, there are certain applications, there are advantages and disadvantages when one need to use a wireless communication system. So in wireless communication system also, I just spoke that there could be different types there, like in WLANs, Bluetooth, Zigbee and cellular communication being one of the important ones. And then we talked about what is the basics of the cellular communication system. I mean how the concept started with, okay, and what was the need to do that, because you wanted to support more people, but the restriction or the shortcoming was you don't have that many frequencies, that much bandwidth. In a limited bandwidth, you want to support unlimited capacity, unlimited people. So there came the concept of the frequency reuse there. So which you call it as a cellular system there. Now the concept of cellular communication is very, very old, going up to way back up to 1940s or 50s there. Let us now see how this cellular concept remains the same. That is, you divide the entire range of frequencies into small cells. A cell means one base station, a low power base station with an antenna supporting a small range, and then that will be using certain set of frequencies, and again it will be repeated into next cluster. So that is, cluster means set of cells, and then the same cluster will be again repeated there. But the underlying technology, the modulation scheme, the kind of communication between the mobile and the base station, the data rate supported, the applications, that has not remained so. Concept is reuse only, frequency reuse only. Concept is cell system only. Till now, in 5G also, it has been modified a little bit. But what thing you need to remember is that what has changed over the years. If the reuse concept and the cellular concept has not changed, then what has changed? What things have progressed till now? So that is what that progression they are catching up in terms of generation. They call it as generation. Like in the first kind of IMTS and IMT, what I spoke, wherein the cars were having long antennas installed on their roofs. That is what your IMT, and then it was MT, and then it was improved by IMT. So let us see what are these generation. Please understand, generation indicates that what is the underlying modulation scheme, what is the underlying frequency spectrum supported, what are the applications, what are the limitations, what specifications must be used by the mobile phone, what is the speed. So these are the main important things that separates from 1G, 2G, 3G and 4G in terms of speed, in terms of applications, in terms of modulation techniques or technical specifications. Am I clear? Am I clear?
Yes, ma'am.
Yes, please.
Yes, ma'am.
Yeah. So in the figure also it is very clear that you could see that they are shown in terms of speeds. So first generation least speed, just supporting a, see again you understand, please understand, 1G, 2G, 3G, 4G, underlying the how the signal is being transmitted, the transmitted signal may be in the form of digital communication or it may be using analog communication. That you must be clear. Any generation may be using analog communication or digital communication. So what you see in the first G, you can see that it is an analog based protocol. It means that signal was transmitted in analog form. There was nothing, no concept of digital modulation or digital communication. Only from 2G, second generation onwards, there is a digital communication. There is a usage of digital modulation. That is the main difference between 1G and the next 2G, 3G, 4G and all. Only the first generation cellular system is analog, whereas 2G, 3G, 4G, 5G all are digital. Now, when I say analog communication, then you could ask me the question, how you are talking in terms of kbps? Because when I say about kbps and all, you will usually talk about that when you are in a digital communication mode. We don't have bits, right? There is no concept of bits there. But if you are taking that analog system and if you are going to express in terms of its digital counterpart, it can be assumed that it may support a 2.4 kbps data rate. Very low, very low. Why? Because the first generation aim was just to support voice services, nothing more than that. Whatever the voice communication you are doing with a landline fixed phone, just you want to replace that with the mobile phone. That was the only target. But whereas if you come to second generation, now the data rates are increasing 64 kbps. Now you see here designed for voice, still voice communication, but it improves coverage and capacity as compared to first generation. And then the first generation standards were called as GSM, that is in Europe and all, okay, Europe and rest of the countries, whereas Japan and all, they used CDMA, code division multiple access. And we all in India also followed GSM as the second generation standard. This was around 80s and 90s there. And then comes third generation, again designed for voice, but with some data consideration. Means not just voice communication, you can also use your phone in order to browse the website, in order to have some data, directly the messages being transmitted. So earlier 1G and 2G, the focus was not on data, focus was only on voice. 3G focus is on voice as well as simultaneous, you can use your phone as laptop, you can use your phone as computer. Like in I can exchange multimedia data, I can exchange text and I can browse on the internet. So internet support was not there in 2G, definitely no need to talk about 1G also. And this was the first mobile broadband. I mean, you can view your video, at least some not a good quality, but a video can be viewed on the 3G. Now coming to your present day, what you are using and which is the foundation for the next 5G generation. You can see that 4G is designed primarily for data. Now, because people are transmitting voice also as data, that is the very basic concept of your 4G there. Why? Because it is not assigning any different space for voice communication. Data, how you transmit the data, same way the voice is also being packetized and transmitted. So it is a complete IP based protocol, which you call it as long-term evolution. The technology, underlying technology behind 4G is called as long-term evolution. Whereas underlying technology in second generation is either GSM or CDMA. And third generation it is wideband CDMA. Now this is a true form of mobile broadband. Why? Because you are able to watch your OTT platforms, you are able to watch your TV serials, you are able to watch your games, do online games, everything in the fourth generation, and it is supporting 100 Mbps of data. Just check, 100 Mbps of data, and the data has been keep on increasing. Now this is one slide which will give you a complete technical aspect details about each of the generation there. 2G, 3G, 4G and 5G, and here I have given you, because even if I explain this, you need to remember before you go for the interview, you need to remember some aspects: bandwidth, the underlying technology, and the multiple access system. At least these things there must be on your mind there. Data rates, as data rates already you had in the last slide there, and what are the applications of the different generation. See here, the oldest one, 2G, established in 93, whereas 3G came around in 2000, 4G around 2009, and now what we are talking is 5G, which is ready for deployment now. And then I told you the underlying technology. Technology means the modulation scheme, the coders, the codecs, voice codec, and your video codecs, all those codecs, all those things, underlying control signals, access technology, everything what you call it as is nothing but the technology, which is called as global system for mobile communication for 2G. And 3G, it is called as wideband code division multiple access. And then 4G, the underlying technology is LTE, which is long-term evolution, which is basically nothing but it is using a OFDM, orthogonal frequency division multiplexing technique, multiple access as the modulation technique, and it is also using a kind of MIMO, that is multiple antennas at transmitter and multiple antennas at receiver. And there is also a technology of WiMAX. Whereas 5G, when you come, it is focusing more on MIMO technologies, I mean more on multiple antennas, so that data rates can be increased, and it is supporting the gigahertz range, so that is, you call it as waves. Till now we explored only up to UHF, SHF kind of frequencies, but 5G is also trying to put data onto waves, which are very short waves. Right. Then what kind of connection was there? Switching type is nothing but connection between the users. I mean, whenever I am on an active call, let us say that you and your friend are talking, what is the kind of connection that is existing between the parties? That you call it as circuit switching for voice, whereas 2G used packet switching for data. It means that in your computer networks, I think you all know the difference between circuit switching and packet switching. Is it? You know?
Yes, ma'am.
Do you know the difference between circuit switching and packet switching?
Yes, ma'am.
Yeah, so you understand, in 2G, for voice they use circuit switching, and for data they use packet switching. Whereas when you come to 3G, the circuit switching was dropped. So only for a very small part, that is your air interference part, everything rest was for the packet switching except for the air interference. Only air interference was for the circuit switching. Whereas 4G is a complete packet switching, whether it is voice call or data call, it is a kind of packet switching. 5G also definitely packet switching only. Whereas if you talk about internet service, it gave a very limited internet or browsing experience, and that was because it was a narrow band. You didn't have video calls, conferences, etc. were not supported. Whereas 3G started supporting a kind of video call and high bandwidth application. Whereas 4G, it is ultra broadband. You know that you are watching your movies on a small cell phone, which is supported there. Whereas 5G is not just aiming at ultra wideband, it is also talking about wireless world wide web there. Okay, high speed internet access there. And then talking about bandwidth, 25 megahertz, here also 25 megahertz, the capacity is very less, whereas 4G is supporting 100 megahertz of bandwidth. You can just think how much capacity it has increased, 4 folds. Capacity has been almost increased by 4 folds. If this was supporting 100 calls simultaneously, then here it is supporting 400 calls simultaneously. And whereas 5G is extremely very high bandwidth, around 30 gigahertz to 300 gigahertz. Why? Because it is not limiting only to voice communication, it is also supporting IoT communications and tactile communications. And then coming to what are the advantages, you were supporting some multimedia features like in SMS and MMS, internet access was allowed, but to a small extent. And then the subscriber interface module was introduced for the first time. And then in 3G, it led to high security, and then international roaming was supported. In 2G, you had to buy a new mobile if you want to move to a different country then. Whereas the advantage of 4G is speeds, high speed handoffs and global mobility is supported. So extremely high speeds and low latency so that it can support time critical applications. Whereas what are the kind of applications supported in 2G? Just supports voice calls, nothing more than that. Maybe some small messages. So main application of 3G is video conferencing. So you could do a video conferencing like calling on a Skype and all. Then mobile TV and GPS. GPS is more important. Okay, tracking and all. It supports for tracking applications. Then coming to high-speed applications, mobile TV and wearable devices was the kind of applications targeted by 4G. Whereas now 5G is targeting onto IoT, it is targeting onto high-speed video streaming, and it is also targeting onto very low latency and high reliable applications. So this is another this one chart and comparison. Same, some points might be repeated here, but you can still make some sense out of this. The speed was not covered in the earlier slide there. So now you could see that just 14.4 kbps, which is a very low data rate. Why? Because the form of communication was analog. Whereas when you come to the 2G, the data rates have increased from 56 kbps onwards. And then whereas 3G, it is not 14.4 kbps but 14.4 mbps. Whereas 4G already promising, I mean peak data rate is 100 mbps. It may go up to 1 gbps, but that is not the kind of actual data rate supported. It is far less than. Whatever the data rates are mentioned here, they are almost the peak data rates there. Here, difference again. There it is only voice only, data analog voice, MMS, web browsing, universal access, portability, video calling, HD streaming, portability, increased to worldwide roaming. So how the wireless communication or cellular communication technology has advanced or evolved in India is like initially GSM was used. I told you that the Europe and rest of the countries use GSM there. 2G, that is we were using 900 megahertz was allocated by government, and also they used 18 megahertz band there, and this was divided among Airtel, Idea, Vodafone, Aircel and BSNL. Whereas in the 3G, which is the underlying principle, this concept used is code division multiple access, and the frequency band in India used was 850 megahertz, which was by the Reliance people were allocated some frequencies and was shared by BSNL and Tata. And then WCDMA 3G, that is again band is 2100 megahertz and 900, and again these are the players there. WiMAX, this is the frequency range, and the operator was only operator was the BSNL. Only BSNL was offering this WiMAX technology. Whereas coming to 4G, the bands used allowed in India are 1800, 850 megahertz, 2300 megahertz, and 2500 megahertz there. And these are the players. These are the players there. So coming to some of the specifications of first generation mobile phones, which you call it as AMS. AMS is the name given to 1G, which stands for Analog Mobile Advanced Mobile Phone System. So the Advanced Mobile Phone System. So this is the name given to first generation cellular system, Advanced Mobile Phone System, which is your first generation of wireless or mobile telephone technology. It was introduced in 80s and completed in 90s there. So first cell phone introduced, which was in analog in nature. So whatever the picture, this was the oldest analog phone that you had. This was in the 1G, it looked like this, very heavy, and it is almost look like a radio that is being today used by your police people then. So voice calls in one country and data rate is very, very, very less, 2.4 kbps, just 2.4 kbps. AMS was first launched in USA for 1G and different frequencies and signaling were supported, and underlying technology was PTT, MTT, AMTS and IMTS. So all these were progressing and coming up to IMTS was the first generation. What was the basic problem with the first generation phones? It was poor voice quality. Why? Because it was just a substitution of wired voice communication to wireless voice communication. That was the only advantage that you had there. That's why poor voice quality, and then battery life was very, very short, and then limited capacity. Users supported were very, very less, maybe 10 or just 20 simultaneous users, not more than that. Definitely no security because it was n-lock, and providing security in n-lock form is almost near to impossible. And then the poor handoff reliability, and then the large phone size, which is very, very heavy to carry in your hands there, and people were really like not liking to carry so heavyweight phones there. Now coming to the features of second generation, that is your global system for mobile communication. The underlying technology is called as GSM. In 1G you called it as AMS, in 2G you are calling it as GSM, Global System for Mobile Communication, which was basically launched in Finland in Europe, and it supported up to 64 kbps of data rate there, and the main features were the voice was digitized. It was not analog form, because everything is packet based here now. The voice part was digitized there, and then you also supported some text transmission, and even the images could also be transmitted, and a multimedia messaging service was also supported. It was leading to a little better quality and capacity. But what was the problem with 2G? Why people progressed towards more better standards were? It requires strong digital signals to help mobile phones to work there. Okay, so the kind of radio signal strength that was required was very, very high, and you could see that the radiations could be more. If there's no network coverage in any specific area, digital signals would become weak there, unable to handle complex data such as videos. That was not possible. Now, if you are coming to architecture, okay, so usually people talk about 2G architecture. If you remember the 2G architecture, then what are the changes in 3G, 4G and 5G becomes more simpler. So always for a full-fledged understanding, you can refer to any of the standard books which are available in library or college, or you might be having an e-book. Fully study a 2G architecture, fully study, try to know each and every part of a 2G architecture, because that's the basis. Next, all standards are having a similar architecture, but little bit they differ there. The full difference you will find in 4G, and 5G also is having little differences. Whereas 3G, 4G are almost similar, and 5G is little similar to 4G there. See here, how the whole connection happens here is, this is your device, mobile system or mobile device. So whenever you are making a call, your call will be received by the nearest base station in the cell. So that you call it as BTS, base station transmitting, base transmitting station. And then all these base stations in different cells, in one base station you will have only one cell, they need to communicate with each other, and that is done through a base station controller. All base stations are connected to base station controller. So your mobile phone, your BTS and your base station controller, together you call it as the radio access. System then. Okay. Basic service set. This is called as basic service set then. Now, this is just not enough. You need to connect to the different networks. You need to connect to the landline. You need to have so many other things required for the working of the whole system. So you will have a master controller, which you call it as mobile switching controller. The base station controller will talk to mobile switching controller, which is again in turn able to talk to your landline system, which you call it as public switch telephone network, So in turn you will have something called as GMSC controller. Then the MSC will maintain all these databases like visitor locations, home location register, EIR, and then you have authentication center. So this you call it as network service set, or you call it as the core network set there. So always you will have one radio access part and the other part is the core network, which will in turn connect to the rest of the world there. Okay, whatever are in solid blue line, it means that is the signaling signal that flows between all the components of the GSM system. Whereas whatever you see in the dashed line, that is between the users. User data is marked by dashed line and solid line is between the signaling. So definitely when you are making a call, actual part of the communication is your call, which is the application. So that is your dashed line. But before you make a call, voice call or a data call, you need to transmit the control signals. Whom you want to contact, what is the calling mobile number, what is the kind of IP address. So all those underlying information, you call it as control signal. Always between two entities, there will be a control signal and there will be an actual data there. Now, there was also an in-between technology between 2.2G and 3G, which you call it as 2.5G, and the name of the technology was called as GPRS. Okay, what is it? General Packet Radio System. This was called as General Packet Radio System. So, because people were not happy with the 2G, there were some improvements which were made and some extra additional features were added and data rate was also increased with some changes in the architecture also, and that was, you call it as the GPRS. GSM itself but combined with GPRS, General Packet Radio Services. So what were the features? There it also allowed phone calls, it allowed web browsing, that was the important introduction. Email, it supported email. Earlier 2G did not support the email. Now increased data rate just from 64 kbps up to 144 kbps was increased. Then it allowed the integration of camera phones. Till now you didn't have camera phones attached to your phones there. And then 6 to 9 minutes to download a 3-minute MP3 song, which was not supported in earlier. Now truly you are talking in terms of the smartphone. From 2.5G onwards, a little bit of features of smartphones started to be introduced into the cellular technology. Now, just a little change from your architecture of your 2G. There is no change in the radio access part, that remains the same, but a little changes were made into the core network part, and there was an additional subsystem called as SGSN and CGSN, which was basically taking care of the packet core network. So this was for the voice part, whereas for because you are supporting more email data transmission, this connectivity to the internet was there. So this started, that part was handled by a different subset. Instead of having a core network service set, that was divided into packet core also. And then you were talking to the internet. Earlier you see, in the 2G there was only PSTN, public switch telephone network, landline phone connectivity, backend connectivity, whereas you didn't have the connection to the internet, existing internet servers connectivity. But in 2.5G, that is the main difference there. Now the phone could be used for internet browsing, for sending email, and which part of the core network took part into it? SGSN and CGSN. Now coming to the next generation, that is your 3G, which is from 2000 onwards. So still more data rate was increased. Now it was from kbps, now you jumped to Mbps. All what is that? The advantage is possible only through your highest levels of modulation. So 2 Mbps data rate because of the higher levels of modulation, digital modulation techniques there. Then typically called smartphones, that's what I told. From 2.5G onwards, now the phones, cellular phone, earlier you called them as cellular phones, but now you started calling them as smartphones. Why? Because your voice application or voice connectivity became a less of important, that became a very basic feature, but now people wanted to use that as your full-fledged computer, like a laptop, like your iPad. So the whole phone, all the features of your computer started appearing on your smartphone, and features increased its bandwidth and data transfer rates to accommodate web-based applications and audio video files. So this was a truly smartphone features was implemented in terms of 3G. So what were the new features which were better than the previous 1G, 2G and 2.5G? Provides faster communication, send and receive large email messages, TV streaming. TV streaming was still now not supported. Mobile TV was supported. Phone calls were supported. High speed web and more security. Now you see security concepts started appearing. Video conferencing, gaming. Till now there was no aspect of gaming. Now gaming was supported. And then large capacities and broadband capabilities. Now you see there it took 2 to 3 minutes to download one small MP3 song file, but now it is just in terms of seconds. A same 3-minute MP3 song there. Okay, now what is the difference in terms of architecture? Again, not much difference from 2.5G, not much different from 2.5G, but the little functionalities were changed in terms of radio access. Instead of calling them as mobile station, and instead of calling them as BTS, base transmitting station, and instead of calling it as base station controller, you gave a different nomenclature. You called it as user equipment. It was called as user equipment. Why? Because now it is a smartphone, which is voice cellular phone as well as your laptop. It acts like a computer. That's why it is an user equipment. Now the BTS had more functionalities and had better functionalities and had to do more than just taking a voice call and doing the handoff, IP configuration, mobile IP configuration. So many things were supposed to be done. That's why it is called as Node B now. Node base station. And then this you call it as radio network controller. BSC is replaced with RNC. It is just not a name change, but internally there are so many functionalities that are changed there. So you call it as UTRAN, okay, Universal Telecommunication Radio Access Network. Universal Telecommunication Radio Access Network. So your BSS is replaced with UTRAN. And here almost the picture remains the same. Mobile switching center, SGSM for the packet core, that is, this is for your packet data or internet connectivity, and this almost remains the same, but the change is here. In 2.5G this was the change, this was same as 2G, but in 3G there is a change in the basic service set, but the core part remains the same. And 3G, again one slide just to give you, I found this slide little more attractive, that's why I put it again. So you could again see what changes have happened from first generation to second to third, and in third generation there is a packet and circuit switch, advanced data, multimedia data was supported, applications were supported then. Now beyond the third generation is nothing but our 4G, 5G and 6G. Now, the bearer services are nothing but what kind of 3G applications were supported to the user. So basically we know that we are using phone for calling a voice call. So it is real-time video and voice call. It also simultaneously supported web browsing, that is database retrieval, server access, interactive kind of services like in gaming and all. And it also supported some streaming applications like in I can watch a video, I can watch a small movie on the phone. And then it also supported some background services, that is our email delivery, file download and all. So this is the basic thing which 1G, 2G, 2.5G also supported. 2G and 2.5G supported a little interactive services, but 2G and 2.5G did not support streaming. Streaming started only from 3G, which is multimedia, truly multimedia services, and then the background services are also supported. Now, what was the basic drawback of this 3G systems, 3G cellular system? There were infrastructure challenges, the expensive fees for licenses and services, and high bandwidth requirement. It required very, very high bandwidth there, and large and expensive cell phones. Still, the cell phone was heavy in weight, and still the charges or the pricing of the cell phones was still very high there. Now coming to the present day, which is the very popular one, the 4G standard, which you call it as was introduced in 2004, and you say that this is anytime and anywhere. See the kind of jump in the data rate. That was just 144 Mbps. Now it is hundreds of Mbps there, and then going up to 1 Gbps. And it is completely IP based, no for voice call also, no circuit switching, nothing, everything is packetized, everything like computer network. You treat even your voice calls as the computer network only. So whole concept of computer network is being implemented from 4G onwards, because everything is packet switch. Whether it is data, whether it is voice, anything will be in terms of a true packet switch network is what is 4G. And then this is described as magic. Why? Because it supports mobile multimedia, anywhere, anytime, global mobility support, integrated wireless solution, and customized personal services are supported. So this is what you term it as a mobile broadband everywhere. Now, both cellular and broadband multimedia services everywhere, features are high quality of service. That is what we demand now. We are not stopping at a basic level of services. We want the services from the smartphones and the service provider to give us very high quality. Okay, quality of service has to be improved. Security, because we are doing all our retail transaction, our shopping, our finance management, everything we are doing. So we require a high security, and 4G supports that. Definitely speed, because we are watching a complete movie on a phone there, and we want to download it in within no time possible. Speed is increased. Capacity, definitely. Many people have to be connected simultaneously to the system, and the cost must go low per bit. And what are the drawbacks of the 4G we have? Definitely, for all these things to be achieved, there must be a complicated hardware, hard to implement, more battery usage, because you are using phone for all sorts of applications. Definitely, there is a lot of drainage in terms of battery usage, then expensive equipment for the implementation of next generation networks, and the technologies like in GSM was the underlying technology for 2G, GPRS was the underlying technology for 2.5G, and for 3G it was WCDMA. For 4G you call it as LTE, long term evolution, and there is a committee or group of countries which will decide about the standardization policies and all, which you call it as third generation partnership project, third 3GPP. Okay. And now let us see what is the change in the architecture. I think there is a change from what is that? In 3G you called it as just node B, now you are calling it as E node B. In 3G you called it as node B, now you are calling it as E node B. And in 3G you called it as UE, now you are calling it as EUE. Okay. E stands for all your what is that? Internet enabled kind of thing. Okay. And then E node B, still you call it as VUTRAN. UTRAN it was, and now it is called as EUTRAN. Now you see there, the core network is completely changed. Please understand this one. The core network is a completely different from the rest all of the earlier generation. You have something called as mobile multimedia equipment, HSS, SGW, PGW, PCRF. So these are the blocks, these are the controller systems that will be involving, and they will be communicating with the E node B's there. Just see same like the home location register, home service center you have here, this is gateway services, packet gateway network. So these all are having a particular application, a particular functionality associated with them, and the whole core network functionalities have been reconfigured now, because it is a complete different way of dealing with the backend system there. So core network is called as Evolved Packet Network, EPC. Core network is called as evolved packet network. Earlier it was packet network, but now it is evolved packet core network. And then you are handling your voice also as data packets, which you call it as voice over LTE there. Okay, and there you are having the backend connectivity to PSTN. And if it is a packet network, you need a backend connectivity to your wired internet or the IP networks. Now, this is so complicated. You know that there are smartphones which support the lower generation. If you go into very rural areas, if you go into any remote areas, there might not be a support for a base station controller which works at 4G technology or 3G. So there I require a 2G. There I require a 2G access. When I am into little bit in a metropolitan area and still there are no 4G services, but it is a 2-tier or 1-tier city, there you require 3G systems there. So you need the support for 3G. And when you come to the very metropolitan cities and the capital cities, maybe the 4G is available there and you should be able to access through the 4G network. So I definitely require a smartphone which gives me scaling. Whenever I am my network support 2G, I should be on 2G. Whenever 3G, I should be allowed on 3G. 4G, 4G. So this is so complicated, and you can see that how the whole system works together. How the whole system works together. Now you have to bring the architecture of 2G, architecture of 3G and the 4G together, and how complicated it is. You can see for yourself there. Okay. So this is a combined support. Your cell phone will be using something of this. This is the real-time scenario, what I am putting it here. Now, open wireless access, this is what is being promised by 5G. 5G is supporting a concept called as open wireless application, which is from 2010 onwards. So, 5G still not deployed in India, but maybe happening into this 2 to 3 months there, and already in the other countries it has been implemented there. So you could see that this is a complete wireless communication system with almost no limitation. There is a speed, no limit, distance, no limit, applications, no limit, everywhere. So highly supportable to wireless World Wide Web based on open wireless architecture. It is supporting this open wireless architecture concept. All mobile use mobile IP. That is a mobile that can be attached to several mobiles or wireless network at the same time and requires smart antennas. That is the main difference in terms of hardware. Provides encryption, flexibility and antivirus. What are the features of 5G? Definitely very high speed, capacity is also very high, data transmission in terms of tens of Gbps. Multimedia, newspaper, it acts like that. You can watch, you can the watch that you can use will be supporting the 5G technology. The TV will also be supporting HD quality data you'll get, high definition quality of data you can expect, large phone memory, diagonal speeds, clarity in audio and video, interactive multimedia, voice streaming video and VoIP, and more effective and attractive. Where are the applications? Business and industry, schools, colleges, doctors, pilots, police, vehicles. Most important is vehicles are also being used using the 5G for supporting vehicular networks. Now again, just see the infrastructure, just see the architecture. Right now there is a release 16 also by 3GPP. Now whatever this is in terms of, I think that this what the slides have taken it from the discussions that were done in 2021 slides there. So this was about the release 15, there is also a release 16 there. Again see the difference, okay, you had E node B, now you are calling it as G node B. You are calling it as G node B, and again UE. E neutral is gone and you are calling it as NG stands for new radio, and then NR. And then you see the core network completely different. This is called as software virtualization or network virtualization. It is using some kind of everything virtualization in the sense instead of having hardware dedicated to each functionality, everything is softwareized, everything is handled in a software way. All the functionalities are done through a software method, not something hardwired. It is softwareized, which is taking lot of AI kind of technology. There is a lot of AI being used in 5G there. Okay, so you could see that complete architecture is very, very different there. Now again, people are also talking about 6G, okay, but still it is at a very, very nascent stage there. So main thing what people wanted to have in 6G is the satellite phones, smartphones supporting direct satellite communication. Can you think about that? Because if you are talking to a satellite, there is lot of phone battery drainage there. Okay, it's not going to be easy. Directly your smartphone talking to a satellite. Okay, so that is what other than all these other features, they also want to go for the satellite connectivity. That's the most important thing of the 6G. So I'll just share the slides with you. Like this is all a conceptual level. Okay, nothing still implemented. These are what they are aiming for. This is what they want. So this differs from group to group. That's why there's nothing being implemented. This is what a vision, still on a vision level. And as I told you that 5G and 6G are more going to have lot of AI being used there. So this is what I was talking about, network intelligence. They are making entire network softwareized. So in terms of software capabilities. So you see that now the present day wireless communication, cellular communication, they must support machine to machine support, PCs they must support, smartphones connections, tablets must be connected, other portable devices and IoT devices. These all devices must be supported. So that is what we want 5G and 4G there. And where all are the applications? Smart shopping, healthcare, smart cities, industrial IoT, smart home, all these applications are also increasing, devices are also increasing. So if you want to support all these growing things, so you can't depend on 4G or below cellular networks. You have to definitely go for 5G and in terms of aiming for 6G also. So again, a very good slide which will tell you what are the problems and what are the applications that you are targeting from 3G, 4G, 5G and 6G. So this is like traditional network architecture. I mean like some things were fixed there. Everything, every block had its definite functionality. But now we are network softwareization. All the functionalities the network handles, everything is softwareized. There is no thing like particular what system, subsystem will do only this thing. So these are the applications that you had in 3G, how it has been enhanced in 4G and what 5G will be supporting and what they are aiming in the 6G. 6G they are aiming for tactile and haptic internet there. So it is like almost a live kind of internet, a live kind of World Wide Web there. Okay, just a little bit slides. I have focused more on 5G because you may be having questions on 5G because that is the existing technology and the latest one there. Okay, so again, what if you internally go into 5G? Okay, you will see that the 5G is subdivided into basically supporting 3 applications, which you call it as enhanced mobile broadband. I mean just an improvement in the data rate. That is nothing but the enhanced mobile broadband. That is one aim of 5G. And the other aim of 5G is to support mission critical and delay or time critical services like in your manufacturing, your robotics, your vehicle communication, your medical diagnosis. So all that are mission critical application where you cannot have any kind of risk there. You cannot have that the network has stopped functioning, that there is a delay. No such sort of excuses will be allowed there, because you will be seeing a completely different world wherein there is a complete remote operation there. So wireless cars or driverless cars, what you call about. And there is a third target application being targeted, that is, you call it as the Internet of Things. So how we will be connecting millions of devices. So what will be the connectivity behind these devices? So even 5G is aiming for IoT. Even it is trying to support device to device or machine to machine connectivity. So you can read these all other parts. I'll share the slides with you. So you can see what are the key capabilities of 5G there. So it is supporting ultra reliable and low latency communication is one big area which it is focusing, and it is also focusing at the simultaneously massive machine type communication, that is for the Internet of Things, wherein you can connect millions of devices to the Internet. And the one which is a regular trend with the communications generations of cellular standards is it is supporting higher data rate, which you call it as enhanced mobile broadband services. Again, the same thing, but in a different way. It has been like what kind of features or specifications you are looking into each of these 5G applications, sub-applications. So again, it has been given, what do you mean by massive IoT? That is, when you want to connect in a massive IoTs, you are looking for low complexity, you are looking for low power modes, you are looking for efficient signaling, you are looking for optimized link budget, you are looking for multi-hop mesh management. When you are talking about mission critical applications, 5G should be able to support low latency, efficient multiplexing, and simultaneous redundant links, reliable devices, and optimized systems or signalings. Whereas enhanced mobile broadband definitely want wider bandwidth. You want to operate in mm waves region. You want to use shared spectrum, massive MIMO. It supports advanced channel coding. So again, you see here how the Qualcomm industry has been in the forefront in the cellular communication. They have been a very integral part of the development in terms of the core radio network. Whatever the architectures I explained, most of the core equipments comes from the Qualcomm. Qualcomm is the forefront in terms of cellular communication devices and equipments there. So how the things have moved from 2G, 3G, 4G and coming up to the 5G. Right. So you could see that Mbps to tens of Mbps to 100 Mbps, now you are almost talking about multi Gbps. So you are moving from high speed packet access to LTE, and now you are talking about a new radio which is supporting enhanced mobile broadband services. So these are the new requirements of your 5G systems. Then what are the different spectrums that are supported in 5G? Millimeter wave, CM wave and below 6 GHz. The whole spectrum has been divided into 3 regions for 3 different applications that I discussed there. So it is spread over the whole range of frequency band there. Part of frequency bands is being employed or deployed there, and these are the underlying technology. Massive MIMO it is using, which is, you call it as, instead of using TDMA, FDMA, it is using BDMA, which you call it as beam division multiple access, and it is also using a latency optimized architecture. So how the functionalities are there in the core part of the network. So you could see the exact frequency spectrums that are being used by the 5G system, which are deployed already. So this is which band, from which to which band, because it is completely spread over a very wide range there. Okay. So which bands are used for which applications? Path to 5G includes a strong LTE foundation. So these are the concerned things about the spectrum, the density, the antennas, the waveform, the availability, flexibility, user equipment centric, forward error correcting, reliability, MAC layer. So 5G in terms of spectrum goes for shared bands, wide channels, wave technology. And it supports small cell deployment because that is good for IoT. It helps, it has self backhaul, coordinated RRMs. Then antennas, you can use in MIMO mode or 3D MIMO mode advanced receivers, and it is supporting beamforming. Then it supports OFDM, multi-carrier OFDM, and also non-orthogonal OFDM systems, and it supports the availability is connectionless, grant-free, asynchronous uplinks. There is a lot of flexibility because it supports slicing in terms of you can get high data rate or you can be distributing the data rates. It is using forward error control coding schemes used are low density polar codes, turbo codes, and for reliability is using this kind of channel coding techniques. So some again other features, licensed spectrum, shared spectrum, and unlicensed spectrum. All three are being used for this one. So which range is supporting which kind of communication? This is that slide. And some of the applications of the 5G. Any doubts?